Okay, so this is the spreadsheet to determine the optimal loading, which is the load against which the velocity will be decreased by 50%, which corresponds to the maximum power output zone. So basically here you need to do 5 sprints. But in our practice, we observe that only 4 sprints are necessary. You don't need to go to the 100% body mass condition. But if you want to do so, you can. The spreadsheet is okay for that. So basically, what do you need to fill here? You need to fill body mass, and you need to fill the V0 value that is in the previous spreadsheet. So for the free sprint, you fill the V0 value that you had from that sprint. Okay? Then, for sprint number 1, that's the free sprint that you just did, you type here again the 5, 10, 15, 20, 25 and 30 meter split times from the MySprint app that you can read on the screen, and automatically you will see here calculated the 5 meter average speed. And then the app will collect the maximum velocity speed in front of the 0 kilo resisted load. All right, so that's for trial number 1, no load. Then you go with trial number 2, 3 and 4 with 25% of body mass, 50% of body mass and 75% of body mass. And you do exactly the same. You do a sprint and you film the sprint with the app and you report here the split times. All right. So what do you see here? You see the split times until 50 meters, but then until only 20 and then until only 15 meters. Why is it so? Simply because due to the high load, the athlete decelerated, so we stopped testing after the split here. Typically with 75% of body mass, after 15 meters, it was deceleration, it was too heavy, and the test was over. But it's totally fine because, as you can see here, the spreadsheet takes the maximum velocity into account, 3.1 here, 4.3 here, 5.7 here, and it reports that here in the table in front of the load. So basically at the end of the testing you have 4 points, load versus velocity, which means maximum velocity you can reach with that load. So you don't need to calculate friction because it's all velocity based. You know the load, you know the velocity, the maximum velocity against that load, and you see the nice linear relationship between load on the sled in kilograms and maximum velocity. So be very careful because we don't compute friction. It's accurate on a given surface with a given sled. So we don't compute friction here. It's a shortcut to estimate the load velocity curve. And there, using V0, and so the optimal velocity, which is half of V0, the equation, the linear equation here, the load velocity equation, allows us to calculate the optimal load for that subject. So it means that 56 kilograms will be the load against which the velocity will be divided by 2. So if you look at the graph here, at 50 kilograms, you have a velocity that's about 4.09 meters per second. Okay, so we will say that 56 will be about the optimal load for that subject. All right, so this is how you determine the load at which you're supposed to reach maximum power, and you're supposed to work against at maximum power for a long duration if you do a full effort with that.